So welcome, everyone. Welcome to Redis Monthly Live. My name is Guy Royce, and I'm going to be your host today. Redis Monthly Live, if you haven't watched before, is a... sorry, I have got myself not muted on my monitors. Amateur move, amateur move, amateur move. Let's kick that off again here. So welcome, everyone. My name is Guy Royce. I'm your host today for Redis Monthly Live. If you haven't tuned in before, Redis Monthly Live is, well, it's exactly what it says. It's a show that's all about Redis. We get speakers from all over the globe to talk about Redis. We do it once a month, and we stream it live here on the internet. So welcome, everyone. Today, we've got three great speakers. We've got Justin Castilla. He's going to be talking about hashtags, which are not just for influencers, our little Redis tidbit of the month. We've got Christian McGeough, who is going to be talking about matchmaking using Redis search. And we have Harshil Agrawal, who's going to show us how to rate limit your low-code APIs with Redis and N8N. So lots of cool stuff coming on down here soon. So let's get started, and let's bring in our speakers here. So, before we bring our speakers in, it's important to pay the bills. So we just like to say that Redis Monthly Live is, of course, sponsored by Redis. We'd like to invite you to check out Redis Enterprise Cloud. If you want to play with Redis really quick and easy without having to download a bunch of stuff and compile it, or set up a bunch of Docker images, you can set up a Redis Enterprise Cloud account for free. You can get a small 30 meg instance that you can use as a cache. You can use as a database. You can use the modules with it, so you can do Redis search or Redis Bloom or one of those modules like that. And so go check that out at redis.com/tryfree. And since you aren't installing anything on your computer to do this, you might also need a client to talk to that Redis. So if you need a client, go and check out Redis Insight. The link here is on screen at redis.com/redisenterprise/Redis Insight. So with that out of the way, that important stuff out of the way, let's bring on our speakers. So we've got Justin, Chris, and Harshil. So welcome, everybody. How y'all doing today?
Very well, thank you.
Doing great.
Doing great, yeah.
Excellent. So this is the part of the show where we banter pointlessly to allow the audience to grow and build up a little bit. And so I've come prepared with a more or less random question that I thought of about an hour before the show. So, and that question for us this week is, what was your introduction to Redis? When did you first hear about it, and when did you use it for like an application? What's your intro to Redis story? So I'm not going to tell anyone who needs to go first. So you guys can sort that out yourselves. Don't let me tell you how to live your life. Justin.
So I actually first encountered Redis when I was a web development instructor at General Assembly. This was years ago. And a student actually brought it to my attention. It's like, I don't want to use SQL because it's hard. I'm like, oh, muffin. But then he showed me Redis, and I was like, oh, data structures in memory. This is intriguing. And so I gave them my blessing. They did great. The final project was amazing, and I was like, I should seriously check this out. And fell in love with it, and I ended up teaching a small course on it within my web development course for people that just don't want a SQL. And then professionally, when I worked in Sauce Labs, we used Redis as a queuing system for automated testing to queue up with some of our virtual servers. So.
All right, I can go next. Awesome. So I got to know about Redis a few years ago when I was just learning about databases, and I was like, this looks interesting. I might try it one day, but as usual, that one day never comes. But I started working at N8N, and I was like, okay, so we have an integration for Redis. Let's try it out. So I started playing around with that, and I then started learning more about Redis. And the first actual app that I created using Redis is what I'm going to talk today. So I'm not going to spoil any beans in this chat right now.
Excellent.
Cool. So like most people, the gateway drug to Redis for me was caching. Back in the day, we used Memcache, which was real fun to administer and troubleshoot. And so we started moving towards Redis. After that, I ran a DevOps consulting shop, and we used Redis for everything from queuing to, serving game tiles to, real-time solutions. We use a lot to stream logs in as part of the Elk stack. So, from the DevOps perspective, we used it for all kinds of things, from a gateway drug to a Swiss Army knife is what we found it was good for.
I suppose I have to tell my story now, don't I?
Of course.
Yeah. So I don't actually have I don't have a good story. I spent a lot of time doing front end development, and so Redis didn't really come into play a lot for a lot of my career. Early in my career, I did plenty of back end stuff in Java and in .NET, but it was all enterprisey, relational database kind of stuff. And then I switched to a lot of front end mobile work, which doesn't really have a lot, a caching component to it in the same way, or using Redis as a database or anything. It was just APIs. And so my introduction to Redis was actually when someone reached out to me and said, "Hey, would you be interested in being a developer advocate at Redis?" And so I said, I should probably figure out what this thing is. And so I went and figured out what it is. And my first thought was, it's a cache. It's in memory, looks like a cache, smells like a cache. I started diving a little deeper into it and realized that it was actually both. It was sort of there's this old skit on Saturday Night Live where they can't decide whether it's a dessert topping or floor wax. And it's like, is it a cache? Is it a database? It's both, actually, was the conclusion I came to. So my introduction to Redis was pretty much shortly before I was hired.
Oh, it's like that character. Is it a Lord of the Rings character or a pharmaceutical drug? It's similar to that.
Yeah. Yeah, it's kind of like that. I feel called out being with the mention of Lord of the Rings characters, though.
I knew that would work on you.
I actually get called Gandalf a lot at conferences and stuff. It's like, he's clearly a wizard. It's like, no, just a wizened geek. So that's the only random question I have, but it's kind of a fun little thing to get to know each other a little bit. Are we ready to get started here? Actually, it looks like we have a question.
Ooh.
Someone's asking a pretty technical question. I think I might save that for a little bit later. Sean, I'll go ahead and show it here. He's asking a technical question. Can you confirm when using Redis with Node as a cache that you need a Redis connection pool similar to when using a connection pool when connecting to MySQL databases from Node? I see someone nodding their head. So
you want to be better looking, you want to be richer, you want to be smarter, use connection pools. For any client, not just Node.js. We run into this a lot. Use a connection pool, and then your life will be a lot easier. So definitely, yes.
Excellent. Any other contrary opinions on the stream here?
No, because it's the same thing everyone else
right
runs
answer,
into.
right?
This one I know I've got right.
Yeah. Just giving everyone an opportunity to dissent if they wish. Yeah.
Well, you can correct me if I'm wrong, but isn't it the whole idea behind having a connection pool for Redis is you have all these threads or connections spooled up and ready to be used rather than starting them up and waiting for that time for them to get up and running. So it's just faster all around, correct?
It's fast all around. A lot of languages like Go, the connection pooling also handles the reconnects for you transparently. And I'll tell you a really good tip is a lot of them like Java, Go, you can set the minimum number of idle connections. If you set that to the number of threads in your application or slightly higher, that way there's always something there. You don't have to make that three-way TCP handshake every time and make things take longer. So definitely use connection pools in any language.
So Sean has a follow-up. He said, is there a preferred library for the connection pool?
Whichever one you're most familiar with. There's too many choices with Redis.
Yeah, I will take this opportunity to plug that there is a new version of Node Redis for Node specifically. I think it's a release candidate 1 right now. So if you want to kick the tires on that, I've been using it myself. It does do that behind the scenes for you. So it does manage a connection pool for you. So and so if you want to give us a little bit of beta test, that would always be appreciated. It's npm install node. It's the one you get, or npm. It's the one you get when you say npm install Redis. Yeah, and Simon is confirming Node Redis version 4 might be worth a look. So
Simon is always correct.
Yeah.
yes, Simon is a very smart fellow. So. Okay, well, let's go ahead and kick off our meetup here. Justin, let me share your screen here,
Thank you.
and then we will get out of your way, and you can have at it.
Okay, cool. So yeah, basically a little deleted scene from the most recent course that we did for Redis University, which is RU301, running Redis at scale. This didn't make the final cut, but this is also pretty interesting just to see how the hashing works under the hood for clusters, Redis of clusters. So I'm going to be talking about some things with the idea that Redis is distributed amongst multiple shards in a cluster configuration. So you can find out more about that, of course, in RU301 for Redis University or in the documentation within Redis. So here we go. First, I want to give you a little bit of backstory. So the how and what. In a Redis cluster, the key space is partitioned into 16,384 hash slots. So basically, we create these locations where we'll store the keys. And the idea is we'll run it through a CR16 hashing algorithm and then mod it by 16,384, which is the number of slots we want to have. And that will give us a consistent key slot location. We're not hashing based off of shards or shard count. It's based off of this magic number, and we'll see why. Over here, I just highlighted basically how all these different hash slots will contain key names, and they can contain more than just one key name, of course, but we'll see that again. And this basically is just a Redis node or shard, and these are all the slots. So this is a cluster of just one shard, and imagine there's 16K different slots in there. So no matter how many shards are added, we will distribute all these shards evenly. So the original hash slot location of a key will be preserved as an expansion or a contraction of the cluster occurs. So instead of having to rehash all of our keys to different locations based on the number of shards, we just have these hash slots, the 16,384 hash slots. So here I just highlighted that this contains all of our hash slots. And then let's just keep track of this little blue guy here. Let's just imagine that this is one of our keys. So I'm going to show you what it looks like when I add another shard. The hash slots will be distributed evenly, and it's still in the same location, only it'll just be on a different shard. So again, we don't care about the shard number, just that numerical location for the hash slot. And this happens with 3 shards, and we can also do it with 4 shards. So if you took RU301 or you want to take 301, this is an actual example of what you would be building for primaries and for replicas, and we'd be able to play up the hash slots within there. And this is this pretty standard distribution of a quarter of all the slots per each shard. So now that we know that, now let's talk about hashtags. Hashtags are simply an additional little substring surrounded by brackets within your key. So I love using the colon within my key names, and a lot of us do that. And after key name, I'll just add substring within curly braces. Now, unlike the standard hashing, which just hashes the entire key name, with hashtags, only the substring is hashed to determine which hash slot the key will be stored. So we're only focusing on substring when we're hashing. So as an example, I actually hashed the string substring, the word substring, and then modded it by 16,384, and that gave me the number 11,435. So that would be the slot number where I would store key name colon substring if that was an actual key that I was using. Now, you can use the exact same substring for your hashtags within multiple keys. That's what you're supposed to do, basically. So key name colon substring goes to 11,435. Key name 1 colon substring goes to 11,435 as well. So you have 2 keys purposefully stored in the exact same slot. And this ensures multi-key commands, which can happen in a distributed system. So multi-key commands, you're doing operations with Redis in 2 different keys. An example would be our popple push, which I talked about a couple months before, where I'm taking 2 keys, key name and key name 1, and I'm doing operations on them. In a distributed system, you have to have your keys in the same hash slot to operate them with a multi-key command. So, like I said, multi-key commands like set operations. So you look at center, sunion, sdiff, all the set operations, list operations like our popple push, mget and mset. They'll only work if the keys are on the same hash slot. And if you don't have them in the same hash slot, then multi-key commands will return a cross-slot error. And they'll just spit back at you nothing. You'll get nothing. So here's an example. I'm calling maybe sunion or sdiff or whatever. This would be great because I have both keys on the same hash slot. So let's see an example of this in use. This is an example using a Redis CLI, but you can easily do this with any kind of client. It's just altering the naming convention, if you will, of your keys. So I'm connecting to Redis CLI, and then I'm going to create 2 sets. So say I'm doing like some sort of social media or social network system, where I have user 447321. That will be my unique ID for my user, maybe. And I'll have 2 sets, one who they're following and one who follows them, so following and followed by. So this user is following Guy, Andrew, Brian, Simon, and Kyle, all of the different talents at Redis University, one of many. And then they're also followed by Guy, Brian, Kyle, Alex, and Suze. So both of these keys are going to be in the same hash slot. And I actually highlighted, you can actually try this at home. You can run the C16 algorithm, and they'll both live in the slot 2161. So when I run s-intersect with the user 447321 with the following key and then the followed by key, both are going to be in the same slot, and I'll get back Guy, Brian, and Kyle, which is the intersection. And that's fantastic. That works great. So it's important to also see a failure. So let's look at that. I'll create yet a different user. So I'm creating user, say, 237114. And I'm using these as the actual hashtag because it would be unique to that user. And I'm adding to their set, followed by Guy, Brian, Susan, Alex, Kyle, O, and Josephine. Now, notice here that their hash slot location is 2514. So now if I run a multi-key command with these 2 keys, say my original user 447321 and my other user, my new user 237114, there's going to be a conflict because they're going to be in different hash slots. And so if I try to run a multi-key command with these 2 keys, since they're not in the same hash slot, I'll get an error, a cross-slot error. So it's actually pretty simple, and there's not a whole lot to it. What you want to do is if you know you're going to be running multi-key commands within your data, you want to make sure that they have the exact same hashtag, and you can implement that with your client by using some sort of unique identifier that is stored within that information that you're comparing. So cool. So that was just a quick little tidbit, a little deleted scene from RU301. If you want to learn more about clustering and running Redis at scale, check out our course, RU301. I also made a little video on our YouTube channel, Redis Inc., that gives you a really quick idea of clustering in Redis that came out, I think, last week or the week before. We also made our certified developer exam free of charge. So take a couple courses at Redis U and then take that exam. It's a fantastic document to have under your hat. And then we're always releasing videos on Redis Inc. So always check out that YouTube channel. And of course, come say hi to us on Discord, on Redis University, or just watch me yakking at you all day on our YouTube channel. And that'll be it.
Excellent. Thanks, Justin.
Thank you.
I don't have anything witty to say. I usually have something witty to say after your talk. So I think I'm just going to say thank you.
I think come up with a hashtag to promote this, or like
Yeah.
not just influencers or something like that.
Hashtag. Yeah.
Yeah, there you go.
Well, excellent. Thank you very much again, Justin.
Absolutely.
I don't see any questions in the audience, but if you have any questions, feel free to post them in chat, and I'll make sure that Justin and Chris and Harshil will see them. And if they don't see them first. So excellent. Well, in that case, then let's hand it over to Chris. Chris, I'm going to bring you into the stream here. So there you are, Chris. And here's Chris' desktop. And now we can say bye-bye, Justin. Bye-bye.
Goodbye.
And welcome, Chris. The floor is yours.
All right, thank you. So today we wanted to talk about making matches with Redis search, and by matches we mean game matchmaking. This is one of the things that a lot of customers come to from the gaming industry and talk to us about. And so we have a bunch of solutions based around the Redis search module that is available on top of Redis. Why is this so important for gaming companies? Better matches means more fun games. More fun games means more user engagement. More user engagement means more success, whether you define that in money or fun amount of the games. And also that faster matchmaking lowers the barriers to game entry, right? As someone who has kids and other things to do, if it takes too long to start the game, I might get distracted and go somewhere else. So having that fast match and getting into the game quickly is really critical for a lot of more casual gamers like myself. To do this, we're going to store the user profile in a Redis hash data structure. We have the MMR, which is the matchmaker ranking. This initially came from chess. The idea being that we're trying to set a number on the skill level of the player, regardless of their experience. So for example, if you're not a good player and you play someone who's really good, they're just going to wipe the floor with you, and it's not going to be a lot of fun, right? So you want to match close to the same kind of player level abilities. The second thing that we're looking at is geolocation, the latitude and longitude. That's refreshed every time the user logs in. And the idea is that, so you're playing a game that requires low latency like COD or something that involves shooting, you want less lag. So if you're playing closer geolocation wise, there's going to be less network traffic lag and more fun gaming experience. There'd be like a blacklist, other players we want to exclude. So for example, my younger son never wants to play with his older brother, and so that he would go on his blacklist right away. As part of the social aspect of gaming, we also have groups. And these would be your first order group associations. And these could be stored in any data store. But at that secondary group level, where we're looking for people who are groups allied with other groups, we're starting to traverse a graph. And here, Redis graph really comes into play for really fast graph lookups. Another interesting idea that was floated when we did some little research was playstyle tags. So we want to classify a user's playstyle. So for example, if everyone's a sniper, it's not going to be a very fun game because they're all just going to sit there slow. So mixing either playstyles depending on the game or having the same playstyle for other type of games might be a better user experience. And the way you would generate these classifications where you could store information on the user's gaming session. So for example, if they cross lots of gaming tiles, if their average shot is really far, if the number of shots is low, right? So you might be able to classify them as like a sniper style. So it's a really good way to use Redis AI as well to classify those real-time statistics that you store in Redis. Then there would be some kind of rating systems like GPTR in case you get stuck with salty language or that's not your cup of tea. You can go ahead and add some ratings as well. And finally, experience the number of games played. So with some kind of anti-fraud or sandbagging, you might be looking at the matchmaker ranking versus the number of games played. If someone played tons of games, but they have a really low MMR score, they might be sandbagging, and that might be someone you might want to flag and take a look at going forward. So we can do the geo search for POP, so POP or point of presence. So we can use a Redis search aggregation query. We are going to aggregate the cities, and this search means we're going to search everything, and we're going to find the cities closest to this geolocation, and we're going to sort and limit this by 1. So similar to a MySQL sort. So just find the closest point of presence for our gaming search. Now we move into straight FT search, so a Redis search. All commands start with ft for full text .search, and we're going to search our game tickets. So a user is going to ask now to join the game, so they're going to create a gaming ticket, and we're going to search for the point of presence Auckland, New Zealand. So that's going to give us a close one. Now we want to narrow down this matching by ability. So we're going to search the game tickets on the pop, and with Redis search, in between these two is an assumed and. So we're going to search for the pop Auckland and an MMR score in this range of 2616 to 2817, right? To find someone who is of similar player ability. Now we're going to filter out any undesirables or anyone we don't want to play with, right? We don't want to play with our younger brother, right? So we're going to search this game tick now for the pop Auckland and the MMR in the range we're looking for. And we're going to minus, which is Redis search speak for not include users Jay Abbott or Hughes Ivan. So we're limiting down the number of people that we want to play with here. Now we're going to prefer by play styling. So again, we're searching on the pop, the MMR, the user, and now we're looking at play style tags, right? We're looking for someone who's a highly mobile player. And you'll notice here that we have a tilde mark in front. This tilde mark means that it is an optional search. So that if the play style is not high mobile, that user will still be returned in the search, but they'll be scored lower, and thus they'll come back lower on the ascending order. Right? So again, it's an optional match. So if we can match on the play style, we do. Otherwise, we just go ahead and proceed. And then we can start to prefer the in-group here. We have this, again, this tilde with the group tag, the light cyan squad, which is a team. And then we can do in-group with secondary, where we're matching that secondary, the olive drab posse, as a secondary group tag so that we get as close as possible to the actual users. So Kai, if we could switch the share here, we're going to run these commands in real time. Okay, here we go. Okay, so here we have our terminal. Fire up our Redis CLI. I'm going to go ahead and run these commands in real time. So I sacrificed a live chicken to the demo gods this morning, so hopefully this will work.
Could you increase the font size a little bit? I believe the correct word is, the technical term is embiggen.
Embiggen?
Yeah. It's a perfectly cromulent thing to say.
Is that, no, cromulent, good word. Okay. Is that easier to see there?
Yeah, I think so.
Okay. So we've gone ahead and we're going to take a look at our cities. So we're going to use an aggregate command here. We're going to say aggregate the cities, and we're going to search all of them. And we're going to load the location field and the city name. And we're going to apply our geodistance location function here. And we're actually going to sort them by this distance that we calculated. So by default, this distance is in meters. You can obviously change this to use miles or kilometers. But the idea is, so if we search within this location, which is going to be my home, you'll see that I'm closest to San Francisco. The next closest city is San Jose, then Sacramento, and then Los Angeles, the home of the hated Dodgers. But for the actual search, when we do it for here, we're just going to search for the closest city. So again, we can search by geolocation to find the closest one. And when you log in, this is part of your login process. Right? Our user profiles are stored as a Redis hash. So the hgetAll gets us every single thing in the hash. And this is our user. So like they were pointing out, we like to use these colons a lot. So this user is Lindsay Martinez. And you'll see we have a unique user ID for her, your username, her MMR, experience, the number of games, we have her location, and we have her at the pop Auckland, which we would update kind of every time she logs in, as well as any tags and other sources around her. So say someone logs in, say I log in, and now I'm looking for, and I move to Auckland and I'm trying to find a game, so I can go ahead and I can search all of the game tickets. And you can see here that West Jane is at the top, right? And then the next user is Charles Heather. But that search is everywhere. Charles Heather is in Joburg, or sorry, she's in Joburg and he's in Newcastle. That's way too far away network-wise. it would be awful. So let's limit our search to the pop, Auckland. And we can scroll back up and we can see here that we have our top user is now Carl Mullen, right? Close in MMR, right? And then this Martinez Marie, her MMR is really low. So this wouldn't be a very fun game because these two users are pretty far apart from where I am. And I would just mop the floor with most of them. So let's go ahead and limit our search even more using the MMR in this range between these two numbers. And let's limit this to 0 to 2. Just get the top couple of users. So now we have Jay Abbott as our top match and Hughes Ivan is our bottom match. And actually Hughes Ivan is my little brother. I don't want to play with him. So now we go ahead and we limit our search. Oops, let's limit it to 2. Now you'll see that they're gone. Weaver Scott is our top person now, right? And Chelsea. So these are more of our matches. They look closer. And we're going to go ahead and look now more for groups. We're going to find someone in our group. We're going to narrow down to our group. And let's limit this again. Limit 0, 0, 2. And you'll see now that Chelsea has moved up, right? Because she's in the light cyan squad, which is the group that I play with. And you'll see now that her play styles also match mine as high mobile because we search for that as well. Right, and finally, to get a real explanation of how this is all scored, I'm going to run this. And we're going to add with scores at the end. We're also going to add the secondary group tags. We want to find, so the light cyan squad is allied with the group Olive Drab Posse. And now we want to see how this goes. So we can do this and let's limit this to 0 and 4 because we'd only have a group of 4 players in our game. We can go back and we see Lindsay Martinez has now moved up to the top, and this is ordered by score. You can see her here. She's got a 3.399 match because she matches the same playing style, high mobile. She matches the Olive Drab Posse, which is our secondary group. She matches our light cyan pack, which is our primary group. Her MMR is close to mine, right? And you can see now, and her pop is the same Auckland. So she moves all the way to the top. The next best match user is Chelsea 17. She doesn't match the secondary group tags, so her score is less. And Scott Weaver is down because he doesn't match any of the group tags. And this user Fallen doesn't match any of those as well, but still meets our parameters that we have to have, which are our pop and our MMR and not part of our blacklist. So that's how we narrow down the matching. In the fuller demo that we do, if you're in the gaming space and you're interested, we did this talk for Gama Sutra, but we can do it for you as well if you'd like. We talk about how we also use Redis to add real-time statistics to the gaming experience, both the matchmaking and the business side. So if you're interested, please feel free to reach out and let us know. But that's how we match you with the best players to get the most fun games going forward. Thank you.
Excellent. Thank you, Chris. So what games do you like to play? Out of curiosity.
Well, see, I like to play games where I can still beat my children. So we play older games. So there's actually in the East Bay, there's an 80s arcade. So they have Joust where I can mop up the floor with my sons. But
oh, that's always fun. Yeah.
Yeah, I will play the occasional Call of Duty with my kids, but I lose to them, so it's not as enjoyable for me.
Yeah, I've gotten into the habit of playing. I'm a big fan of base builders, so that's not really a competitive space. It's more of a suck you in and scratches the same itch that programming does sort of game. So
you can't talk smack in that kind of game, which is I think is the most important factor for my children in gaming.
Yeah. There is a degree of that as well. I did play GTA 5 with my kids for a bit, but my kids are obviously teenagers. Just
Dad,
to be clear,
all the F-bombs. Yeah, not a good idea, man.
Hey, I don't know why my son got a detention for dropping an F-bomb in school today.
Yeah. Where'd you learn that, son?
From Dad. Yeah.
So Dad controls the cookies in the house. Don't do that.
Yeah. So Simon agrees that Joust is fantastic.
I told you Simon was a really smart guy.
Yeah. And Simon also owns an outrun machine.
Oh. Nice.
So nice. So, well, excellent. Well, thank you very much, Chris. And I don't. There's no questions in chat, but if you have anything else you want to say before I kick you out of here, yeah.
If you're in the gaming industry and you're interested in how to use Redis, please feel free to reach out to your local sales associate. We can run through all this in much finer detail and with more uses for Redis in the real-time gaming space.
Excellent. Okay. Well, thanks a lot, Chris.
Thank you.
And I'm going to bring Harshil on next. So, see you later. Hey, Harshil.
Hey,
Welcome.
thank you so much.
So, everybody, this is Harshil. He's with N8N, and he's going to talk about how to rate limit your low-code API with Redis and N8N. So, I'm saying that right, ain't I? I'm not butchering the company's name. It is literally just N8N.
Yeah.
Excellent. Well, the floor is yours.
Thank you so much. All right. So, hello everyone, and welcome to my talk. Rate limit your low-code API with Redis and N8N. Now, before I jump into everything, let me give you a quick introduction about myself. So, my name is Harshil Agrawal, and I work in the developer relations team at N8N. I love experimenting with tech, and I'll sometimes live stream those experiments on Twitch, and I also often share them on my YouTube channel. So let's get to the story over here. One fine day, like everyone else, I decided that I wanted to update my personal website, like just for no reason. I thought of moving my blog from Ghost CMS to MDX. Now, if you are not familiar with any of this, it's all right. All you have to know is that Ghost CMS does not return your content in Markdown. So it returns your content either in mobile docs or in HTML. While I wanted to move to MDX, I needed my content to be written in Markdown. So I started to look for a solution to transform my blog content from HTML to Markdown. And I found a couple of useful packages and web apps. But they were not really useful. They were more of a one-time solution. So if I wanted to convert a new content that is in HTML, I'll have to copy the HTML code and process it through either that package or either that web application. Hence, not so useful. And that's where I ended up creating an API with N8N with only just 4 lines of code. Now, to give you an idea of this particular workflow, I'm going to walk you through it. So the first node you see that is named as webhook for URL, it basically triggers the whole workflow whenever I make a call to that particular webhook URL. And with this call, I am passing a URL of the HTML page. The HTTP request node gets that URL from the webhook node. It makes a request and it gets all the HTML code for me. And then using the HTML extract node, I am extracting the information that is stored in the body tag. And in the function node, I am using an npm package, which converts the data from HTML to Markdown. So this was working really fine for me because now every time I create a new content on Ghost, all I had to do was pass on that URL, and this workflow would give me the Markdown file. Now, after using it for a while, I thought, why not make this API available for others to use? Because in my search, I could not find any such APIs that people could use. So I went to Twitter and created a poll. That's where we do the market research, I guess. Anyways, seeing the interest of a few people, I decided to publish it. So I had the basic MVP already ready for myself. So I tweaked it a bit and added authentication on top of it. And I asked my friends to test it out. Trust me, never ask your friends to test your MVPs. Because this is the result that I ended up with. My friends, being my friends, tested the API in all possible ways. And the result was my MVP broke. So I tried to understand what went wrong and why I encountered this problem. And I learned that they were making a number of requests all at the same time. Since it was an MVP, I didn't set up my server for such for such case. And I never realized that this could be a potential problem for an MVP. So I thought of taking a look again at taking a low code approach, and I thought of adding a wait time using the wait node in n10. So every time someone makes a request to the API, the workflow would execute, but it won't process until the wait time is over. But then eventually I realized that this is not an ideal solution because it is gonna limit all the API calls. So if I am making a request and if another person is making a request, for both of us, it is gonna add a wait time, which is not ideal. And that's where I got to learn a bit more about rate limit. Now I looked at Wikipedia and it pointed out me towards the solution that is widely used by the web servers. So according to Wikipedia, rate limit is used to control the rate of requests sent or received by a network interface controller. So not getting too much into details over here, but it solved the problem for me. So I could now limit the incoming requests, and based on some sort of logic, I could decide if I want to, send them a response, or if I want to give them, if I don't want to send them a response. Going through that Wikipedia article, I also learned that a very key component of this is a key value database like Redis. And guess what? Since we already have a Redis node in n10, implementing this was not so difficult. All right, enough of talking. I am going to show you how to create an API with n10 and how to implement rate limit using Redis. Now, a full disclosure, I am not gonna create the whole HTML to Markdown API because it's gonna get a bit complicated. But what I'm gonna do is I'm gonna create a simple API where a user makes a GET request. It checks for the rate limits, and if the user still is still under those rate limits, we'll send them some response. Now switching to my n10 instance, let me just briefly give you an introduction about n10. So n10 is an extendable automation tool with a fair code distribution model. So the source code is publicly available on GitHub, and you can add your own features and extend n10 as per your use case. And that's what I did for my HTML to Markdown API. All right, now for this demo, I am going to use n10 Cloud, which is a hosted service, but you can also self-host n10 on your own servers. Now, since we want to listen for an incoming request, I am going to use a trigger node. Now in n10, we have two different kind of nodes. A trigger node, which would trigger or start your workflow when an external event happens. So this can be maybe a call on that webhook URL, or maybe something happening in your CRM system, or maybe someone gave a start to your GitHub repository, right? While the regular nodes, they process this incoming request, and based on how you set them up, they would manipulate that data. So it can be adding data to a database or reading data from the database and all such operations. All right, since we are kind of creating an API, we need a URL for that. Now in the webhook node, I get two URLs, both are kind of the same, but when we are building the workflow, we always use the test URL, because with the test URL, we always see the output that we received in this our canvas. So I'm gonna copy the test URL, and I'm gonna go ahead and save my workflow. So this registers my webhook URL. I'm gonna execute the workflow because again, we are still building it. It's not live, it's not active. So I'm gonna execute my workflow, and I'm gonna use Postman to make that API call. If I send in the request, we see a message that says workflow got started. It's perfect. But over here, what we want to do is we want to send in a request with an API key. Again, for the sake of simplicity, I am gonna pass on the API key in the header parameters. But when you are creating your own APIs, make sure you follow the best practices and not pass on the API keys in the header parameters. Let's give it a really difficult value. All right. Now, coming back to NA10, we can see the incoming data that we got from the previous request. I'm going to execute this workflow once again and send in this time the API key. So now if I check my webhook node, over here, we get our API key. So now that we have the API key, we can now identify the users uniquely. So I am going to use another core node in NA10, that's the set node. And over here, I am gonna, since I'm only interested in the values I am configuring in this node, I'm gonna toggle this to true. And in my string, I am gonna call this API key. So this is in a way setting up your own variables. So that's what I'm doing. Now I want that API key that was passed on in the header parameters in this node. So I'm gonna use add expression and get that value from the previous node. So down in the result, we can see that we have the API key. Now, in my original workflow, what I ended up doing was adding two more values to this particular key, which is the hours and the minutes. So what this will do is it will create a new key. It will send it to Redis. It will increment the value, and then based on the check, if it's exceeding the threshold, we are going to send out a response. So let's do that. So the first thing I want to do is I want to use the JavaScript function of new date and then get hours. So we got the hours. We also want to append the minutes. Let's copy this. Oops. Let's replace this with minutes. So over here we have the API key, the hours, and the minute. So now if I execute the node, we see the output. We can switch to the table view, and that's perfect. Now, because I want to increment this value with each incoming request, what I'm going to do is I'm going to add the Redis node for that. As Guy mentioned earlier, with Redis Cloud, you can quickly get started with Redis, and that's what I am using in my demo as well. It really is useful to quickly get started and test out your workflows when you're using Redis. And over here, we want to increment this value. So again, this is coming from the previous node, the key value. So over here, we have the key. And because we want to limit it for a particular time, we want to set expire to true. And instead of 60 seconds, I am going to change this to 3600, which means that it is this key is going to be live or available for at least an hour. So if I execute this node, we get the value 1. It's perfect. Now what we want to do next is we want to check if this value is greater than some value or not. So for that, I am using an if node, which is again another core node in NA10. So you can have all sorts of true and false condition in here. We can select number since it's a number. And again, since we are using this value from the previous node. Now over here is what you can do. You can, based on how you want to do it. Do you want the user to make a request? Do you want to limit the user for 10 requests per minute or 30 requests per minute? It depends on how you want to set it. For now, I am just going to set this to 10 and I'm going to change it to smaller equal to, because if it's equal to 10, we still want to send them some output. Now if I execute this, if I come over here, we get some output in a true branch. That's perfect. So we know that the condition is true and we want to do something more. And that something more is now we want to increment the value for hours. So right now what we did was we incremented the value for minutes, and we are adding a limit to minutes, but we also want to add a limit for making API calls within a particular hour. So I'm going to quickly duplicate the set node, connect it to the true branch, and in here, since it's JSON, now JSON means that it is coming in from the previous node, which is not, it's coming in from the, we want this value from our webhook node. So I am gonna go to nodes, webhook, output data, and again from headers, select this value. Since we don't need all this information, quickly remove that. Right, and we don't want minutes as well. So here we go. Now we are only gonna check for every hour. We now have an API key. And again, I am gonna use a Redis node for this. So I'm gonna increment this value. Let's duplicate it. Connect it with the set node. And we can see that it is now getting the value from the set node. Over here, we don't want to have any kind of expiration. So I'm just gonna turn this off. Execute this, and we have another value, 1. Now, lastly, I want the user to make 60 requests in an hour. That seems fair enough. So I'm gonna add another if node. Select number, and again get this value from the previous node. All right, so we are now getting the incremented value, and since we want to allow them to make at least 60 requests, at most 60 requests, I'm going to select 16 over here. And now this is where it's kind of get interesting. So depending on where your data is stored, you can get that data. For this example, I am getting data from Airtable. Since I'm talking about low code, and Airtable fits that kind of category, so I'm going to select Airtable node. And I already have my credentials set up for Airtable. But if you are new to Airtable and if you don't know how you can create your own credentials, you can click on Create New and click on Open Docs. And this will take you to a documentation where we have mentioned step-by-step guide on how you can create credentials and connect that particular service with anything. Let's use my N10 account, and I'm gonna just list the information. Now Airtable has a unique base ID, so I am gonna use the base ID that I've already created and the table. So if I execute this, I'm gonna get a lot of information from Airtable, and here you can see this all the information coming in. Perfect. So let's try this out. Let's execute it and see what happens. I'm going to execute my workflow and make a request. Okay, we got something. We got message that says workflow got started. But if I come in over here, my workflow also got executed, but I still didn't receive the output. I was expecting to get the name of the Pokemon as well as the URL or some of the information, right? But that didn't work out. Now, this is where the webhook node becomes really interesting. With the webhook node, you can change the response mode from on received to last node. So what this will do is it will execute the workflow, process all the nodes, and whatever information is written by the last node in your workflow, it is going to send out that information. So I'm going to select all entries because I want to send all the list of Pokemons. And now if I execute the workflow and send in the request, we get all this information of Pokemon. So this looks good, but let's change it a bit and refine it a bit so that we get really readable information. Over here, if you see, we are getting the fields, name, URL, and the ID, and this ID is coming in from Airtable, which we really don't want to show to the user. So what I am going to do is I am going to use a function node or a set node, depending on how you want to do it. But let's just use the function node so that you also get an idea of how you can use the function node to write some kind of custom code snippet in n10. So over here, I have the function node. And in this node, I want to send the user not just the information that we get, but I also want to send them a message which gives them the information of how many limits they still have or how many requests they can still make. So let's just quickly do this, const limit, and I'm going to quickly copy the message just to save some time. Now, I am not 100% sure if this is going to work because if you see over here, we have getting this information from the nodes, and I have node which has the node name Redis1. So I just want to make sure that we are getting the correct information. So I have Redis1, that's perfect. But I see a problem here. There's set2. Let's change this to set1, and hopefully this should work. And what I want to do is I want to return an array which contains a JSON object with, of course, the key JSON. And then let's send the, maybe call it message, limit, and then the body. And this is going to be the items that we receive from our table. We are going to map through all those items, and we are going to only return the name and the URL. So let's just do const name and then call this item. Now I am going a bit fast over here because I already know where that information is, but let me quickly again show that to you. So in here, you can see that the information is under fields and then name, right? Over here, I am using the JSON keyword. Well, this is a hidden keyword that is used in all the items that is written in n10. So similarly, we want to do this with the URL. So let's change this. And lastly, this should be an object. So if I execute this, and if I've written the code correctly, this should return us an output. And we got an error. That's completely fine. Okay. All right. So we didn't append. All right. So over here, you can see that we have a message that says limit consumed, and we also have the body. We can again switch to JSON, and we can see those in the JSON view as well. So if I come back to Postman, and if I send this request, we see the limit consumed message. So this tells the user how many limits they have consumed, and also gives out the body. So this was a quick demo of how you can create your own API. Now over here, what else you can do is, if the condition is false, you can have another set node where you send in a message and say, hey, you have crossed your limits, and maybe make a request after some time. Right? You can have such messages sent out in the false branch for both the if nodes. Also, currently, if the limit is crossed, we are still sending 200, a header of 200, the response code. But you can also change that. You can also set that in the set node, and you can reference that value in the webhook node. To quickly wrap this up, now this workflow is kind of complete. And if I want to use it in production, what I can do is I can activate this workflow. Yes, activate and save. And now instead of making request to the test URL, I'm going to select the production URL, copy that, come to my instance, and make a request. And every time I'm going to make a request, you see that our limit is getting incremented, and we also get the information. All right, so that was my story of creating low-code API and implementing rate limit with Redis. Now you can use Redis for different use cases and not just for rate limiting. So right now, the API that I created makes a call to add table to fetch that data. But this can create a latency and can create performance issues as well. So to improve the performance, what you can do is you can use Redis for caching the data. So instead of making a call to add table every time a request is made, we simply return the data from Redis. The other thing that you can do is you can use Redis for data storage. So you can also create workflows that store data in your Redis database. This can be really useful when you want to store and access data across multiple executions. And I quickly want to share this workflow that one of our community members created, which is using Redis to store the data. This community member plays sports at a popular hour, which makes it difficult for them to reserve the code. So they created this automation which reserves the code for them. So they don't have to worry about anything. This workflow runs in the background, and based on their calendar availability, based on the weather, it reserves a spot for them. Another important use case of Redis with n8n is queuing. So based on the user's application, they may want to scale their n8n instance to handle maybe millions of calls. So we added the functionality of scaling n8n. So instead of running n8n on a single server, one can spin up workers that can take the load of the main instance. And we are using Redis for queuing this. Well, that's all, folks. I hope you learned something new and you would try out creating your own API. If you have any questions, I would love to address them. And yeah.
So, well, there was one comment in chat that this rando said. So that was pretty neat. Actually, we did get one comment here from, I don't know how to pronounce your name, Der Artsdraka. Is going to be my guess, which his comment was, this is really cool. So, and he's right. This is really cool. It's really cool that this integrates with Redis, but it's also really cool that you can just it's that drag and drop programming. I've seen a lot of attempts over the years at drag and drop programming. The low code thing is sort of the new word for that. And this one feels like it's a lot closer than a lot of others have gotten in the past. It's got the right level of integration where I can go in and do the code where I need to, but where it lets me drag and drop all the common scenarios that I want to do. So it looks pretty slick. So good work to your team. Good job.
Awesome. Thank you so much.
Are there any other questions out there in the crowd before we wrap this up tonight or today? I guess it's tonight for you, isn't it, Harshil?
Yeah.
So, okay, well, I'm going to go ahead and bring everyone else in here. Just to say, everyone, thank you for attending today. Let's give a big virtual round of applause by saying clap emojis in the chat here for Chris and Justin and Harshil for presenting for us tonight here. Yeah, thanks a lot for doing this. It's there's not a show if you all aren't here, so it's much appreciated. Got a question here, actually, from Ravi Lochin. Can we implement job queues with Redis? Absolutely.
Yeah, Sidekick uses Redis under the hood, and it's very easy to integrate. It's very commonly used.
Yeah, that should be possible with NEN as well, right?
Yeah, it is possible, but I haven't tried it yet, so I don't want to give a wrong answer over here.
Fair enough. Fair enough.
But I would appreciate if they try out, and if they have any questions, they can always reach out to us via the form.
Excellent. Is there anywhere, actually, I forgot to ask this, Harshil, where we can get, actually for all of you, any of the sample code or some of the slides and stuff for your talks today?
Sure. So I'll send it to you, and maybe you can then share it with everyone else. And I'll also add the workflow that I have created and share it on N10 so that other people can try it out.
Excellent. I'll post it in Bevy so everyone has access to it. So, and by Bevy, that's meetups.redis.com. So that's the internal name for it. So, well, excellent. Well, thanks a lot, everyone. And let me bring up a little don't miss out next month. So we don't have the speaker details lined up yet for next month. I've got a speaker, but I'm still waiting on a talk title and abstract. So we do have a speaker scheduled for next month. If you don't want to miss next month and don't want to miss subsequent months, join us at Redis live at meetups.redis.com/RedisLive. You can subscribe to our YouTube channel, which you're probably watching us on right now, youtube.com/RedisInc. And you can also follow us on Twitch at twitch.tv/RedisLabs. And of course, we have a Discord server. Justin plugged this a little bit earlier, but many of us, Harshil included, are on the Redis Discord server, so you can reach us there and give us a follow on Twitter. But discord.gg/Redis. And I'm one of the admins there, so I'm always on there. Justin's one of the admins there. He's always there, so we're there constantly. So if you got Redis questions, feel free to reach out. And I got a speaker for next month, but we always need speakers. So if you're looking to give a talk, if you've got a cool Redis story you'd like to share with everyone on stream here, then reach out to us, perhaps on the Discord server, and let me know what you're interested in speaking in. I tend to view meetups as sort of a open mic sort of thing. If you're getting started speaking, you got something you like to do, I'd be happy to host you. Just let me know. You can email me guy.royce@redis.com or just message me on Discord. And that's what we've got. So thanks again, everyone, for joining us, and thanks again for everyone speaking. And any closing words? You're stunned silent.
Don't be a hash slot.
Yeah.
I'm going to start calling my son that now when he forgets to do something.
Well, hashtags just aren't just for hipsters anymore, right?
Yeah.
Or influencers. Sorry, not hipsters. So, excellent. Well, thank you very much, everyone, and have a good day.
Thank you.
Yeah.
Bye.